Morning, guys. I'm Denish. I work with Postgres, Oracle, MySQL, SQL Server, NoSQL, and a lot more databases. And you could reach me at Denish@omniti.com. And at OmniTI, we provide solutions for different business problems: scalability, reliability, HA, consistency, security. And if you are looking for a job, we are hiring on different groups like SAS and DBS and application developer. Today I'm going to talk about HA. So the agenda for this talk is to why do you actually need a HA architecture, and how Postgres can help you to achieve the goal for the HA architecture. I'm going to describe the way I usually see the traditional HA architectures at various clients, and the goals for maximum HA architecture, like within 99.99% availability. And this is one of the solution we came up with. Like, there are plenty of solutions out there, but you have a choice, and there are a lot of things you consider choosing any solutions. Its cost, all kind of resources you have to achieve that 99.99% availability. So I want to make a couple of assumptions here. One is the cap theorem. If you don't know, it's like you can achieve consistency or availability, but the P is like a partition tolerance. That's not I'm going to talk today, because we would like to have a database to be consistent and highly available. The other thing is actually a fact, not assumption, because you can't control the MTTF. It's mean time to failure. So if you bought a new car, it can break anytime. You never know, right? Because you can have accident in 5 minutes or 5 years. So you don't have control on mean time to failure, but you have a real control over MTTR, mean time to recover. So if you have money, you can buy a new car in 5 minutes. So you have to be ready for that. So that's the difference. Like, most of the people just trying to achieve mean time to failure, but there is no real control, because everything is built for failure. People fails, system fails, everything fails sometime. So we should actually concentrate on mean time to recover instead of mean time to failure. So that's the fact and assumptions. And before I dive more into talk, I would like to be frank about what's my goal about this talk. My goal is not to accept whatever I say here and implement that. Just review that what I'm saying here, what are my philosophies here, and just make sure our architecture is trying to achieve that or not. It's like a view from my point of angle. It's not the decision I'm going to make from your side. So why do we need HA architecture? First thing is whenever there is application downtime or there is no data available, there is a loss of productivity, loss of revenue, and dissatisfied customers. So to avoid those things, we need a HA architecture at each and every level. It could be application or database or systems. So I categorized things in two parts. Like, there can be two kinds of outages: unplanned and planned outages. I don't know if anybody has any other outages, but usually from the top level I see two kinds of outages: planned and unplanned. In unplanned outages that could be system failures or data failures, or it could be network failures too, but I think I would put under system failures. And planned outages, it could be a system changes because you need to do something like upgrades and all those stuff. That's what people hire us. So that's always ongoing. And the data changes because if there's a data is static, we are not here anymore. I might be using text files. Oh. And we would like to prevent. I am not saying that we don't have control on mean time to failure, that we don't have to put resources to prevent that. We should. We should prevent that, tolerate. Like if, because sometimes system fails weird way, like it fails completely or in the fuzzy state. So it should tolerate some of the systems failure. Like if somebody takes out a power plug from the database systems, then it's when it comes back up, it should tolerate the recovery and recover fast. That's the goal, right? If once the system fails, we know the system failed, we got the page, and we should have policies, procedures, and the personnel in place to recover that fast. I think I'm not big fan of automated failover. I think last week we had an issue with the GitHub. They had an automated failover. They failed to one of their failover system and it tried to fail back. So in this talk, I'm not asking you to do any automated failover, and we are not doing anywhere. We have the scripts, steps, and procedure in place for the manual intervention. We need some kind of manual intervention for the failover. I would do for one-way failover, like from the failover system, but not the reverse. Like once we failed over once, make sure somebody from the systems or DBA group looked into that and then decide what to do instead of failing over back. And Postgres has a limitation on failing over back because you have to rebuild the standby database. Okay, so why Postgres? Why I chose Postgres? Because there are tons of tools out there that I can choose, and I don't have, like, there is no, like, when client comes, we usually go and talk about the problems they are trying to solve, and then we decide the tool. So that's our approach. We never go for the tool first and then solve the problem, but first we understand the problems, and then we provide our preference for the tool, and then client decide what tool they want to choose. So Postgres is our first choice because of its lowest cost. There is a cost always associated with anything there is nothing free in the world. Everything, something is associated with the cost. So it's the lowest cost, no additional software cost for maximum HA architecture or something like that. All proprietary systems can provide. And the main part is it is free feature sets to provide our goals, like prevent outages, tolerate. I think that's the best features that Postgres has to tolerate the outage, and the recover fast. Because I have worked in the past with how to recover Oracle databases, it wasn't fun. But now with the Postgres, it's very easy to recover from the systems. Okay, so next is traditional HA architecture. Usually in last maybe couple of years ago, like what we have one master database, one standby database. We save the WAL files in Postgres 8, reply, and whenever there is a failover, we fail over to the standby database. Now in Postgres 9, what we do, we introduce a streaming replication. We do WAL, still we do hybrid kind of replication. So in case of streaming application break somewhere, it still catch up from where it was. So, okay, I think I talk about the goals for maximum architecture. The main goal is reduce MTTR, mean time to recover from planned outages or unplanned outages. Okay, so we have goals. We know, like, we want to achieve that. and we have resources, and but we have limited resources. We don't want to throw like $1 million on it to achieve that. So we have like questionnaire. This is one of the part of the questionnaire. Like we ask client like, how do you manage failover? That's the first question. Like, is it transparent to your application, or whenever there is a failover, everybody knows about it? Like you have to change the application code and reload the config and all those stuff. You do hard backups. Everybody does the backups. So if you are doing hard backups or dumps, are you doing on the production system? Because backups are resource intensive, and if you are taking backup on the master database, means production database, there is a high possibility that because of the high load, it might fail sometime. You do schema backups. How often are they under version control? Like schema backups are important to know, like sometimes we keep everything in the subversion or maybe Git to make sure if something changed and somebody report the problems, we can easily find out from that differences from the Git diff that what's changed. Because for recovering fast, you should be able to find out what changed during that time. So if you don't have that things in place, there is no way like you will be looking around emails and asking for a lot of people. But once you have a centralized repository for the schema changes, then you know like what changed during that time, and because of that, or you can rule out that reason very easily. Files, because we put this checkpoint, like because for one of the client we had, they have like 3 or 4 production environment. Each and every environment has separate WAL files, copy scripts, and there was no centralized things like, and everybody has some different configuration options for that script. So for recovering fast, you should know, you have to know in advance that your script, what your script is doing all over the places instead of one places that are different. So that's another thing we should be careful about. And this checkpoint, last checkpoint came up from like reporting queries. Where is your reporting queries runs? Usually people run like large queries, maybe hours duration of query on the production system. Why? We have very cheap hardware in place. We don't have to pay for any software licensing. Why can't we build a BI, the talk we discussed, we had before? Like why can't we have data warehouse system? We copy the data, we run the query, and there are ways you can keep the reporting server in sync from the production. So that allow that, so that reduce the possibility of failure during large query run. So those kind of things, like it's all small things, but when small things comes together, it becomes big thing, and it will make your recovery time longer and longer. Okay, now I will talk about each outage on separate way and how we can manage in the Postgres world. The first one is unplanned outages. So in that, the system failures. It could be the Postgres database server fails, or storage associated with that PG data fails. Then how we can recover from that? So what we do is, there is a big internet application server. We have application servers, and we usually do the floating IP, VIP thing. It's very cheap to get that, and application always points to that floating IP. It doesn't know which database is master or slave. It always point to, like, suppose you have a website, you have application call, and you want to have two, there is a master 01 and slave 01, something like that. Then you have only prod server as a VIP, and your application only knows about prod server, not what is master and what is slave. So when there is a system failure, you don't have to change your application to let application know that you already failed over. It will, the failover procedure in place will take care of that, changing the VIP, shut down the master server or database if it is still up and running, because sometimes the failure is partial, it's not complete fail. So, and then you fail over your Postgres database. Failing over Postgres database is very, very fast. It takes less than a minute, and you touch that file and bring up the database, test the connectivity, and let application know that you are up and running. So you still like achieve that 99%. Like I assume that you are not going to fail every day for a minute. It might be possible that you can fail like 99.99 is about, you can fail about maybe hour or something in a year. So still it is achievable. Next is site fails. Site means like or facility fails altogether. Suppose you have a data center and you don't have any data outside of a data center. Everything is in that data center and it fails. So I think you should plan for that as well. So what the cheapest option is cloud. I'm not telling that you have to do like you need to buy expensive the instances on the cloud, but at least you should put your database on the cloud. It can have maybe hour lag or 2 hour lag, doesn't matter, but if your colo facility fails, I don't know how you can recover unless you can have offsite backups and all those stuff, but still it will take time to recover fast, right? You have to set up the application servers and everything, but it's with the small instances in the EC2, you should have all the Git repository checked out and everything is tested there. So whenever something fails, catastrophic failure on your production colo facility, you can, it might be not as performant as your old facility, but you have something to go for, and you can upgrade your systems in the EC2, and you can do a lot of things around cloud. So I think it's inexpensive to reserve those stuff. Like you have to calculate your business downtime versus the cost. If you are getting your colo facility goes down and you cannot able to recover in maybe week or so, then you might lose week worth of customers and they might not come back ever. So I think that's something you should look into that. Data failures. We are still under unplanned outages and human error. We are want to make errors, right? So there is a tool called OmniPITR. We have a tool that there are different tools. There is a val E, I think. There are different tools for managing the val files that ships over to the standby database. So for that, we are not using. If we want to achieve this data failures for 1 hour, we don't apply that logs for 1 hour. So it delays for 1 hour. So if we come to know that somebody made a mistake in an hour, we can stop the applying on the standby database and we recover that table very fast. So that's one of the things you can do. We do periodic PG dump, tables on slave database. Now you can do dumps on the slave on starting with PG9. So you do like, it depends on the criticality. Like I have seen like out of terabyte of database, like some tables are very critical. So why can't we dump those tables maybe every day or maybe once a week at least? You don't have to dump entire database. But if there is a real possibility to make that mistake by somebody somewhere, and you can recover that fast instead of recovering from the entire backup systems. And we have a tool called PG Extractor, and I think Keith is going to give a talk on that in the evening. It's under OmniTI Labs. So we have OmniTI Labs. There are different tools that we open source. Whenever we build a tool, there will be open sourced once they are working on the production systems. So that tool can help you to keep track of the schema changes that I talked before. Like you have to run, we usually schedule that tool to run every hour, and it dumps the schema and put into the Git, and we can get the email to see what changed, because we handle so many customers that you cannot have a we are not managing only one database, so we know what each and everything is going on during that time. So we come to know from our emails that if something changed, we don't have to go and ask the developers what was the change about. So that's a good part of it. Any question? Oh, we are still have unplanned outage. Okay, data corruption. Yeah. So for data corruption, it's very difficult problem to solve, because data corruption can happen, and it's very difficult to find out about data corruption in the first place. So we do like sometimes people are very sometimes people don't want to take a backup, because taking a backup takes a lot of resources for large systems, and that slows down the system. So what we came up with, we took approach of using OmniPI to take backup on the slave. We never touch, we just put the backup database, master database in PG start backup mode, and then take file system level on the slave database. So that's very low overhead on the production system. So we can do very frequently. So we have a file system backup like every day for terabyte of database systems without noticing any performance issues. And it takes maybe, for large system, it takes 7, 8, 9, 10, 12 hours. So for 12 hours, your system is trashed out if you are taking backup on the master. So that's what allow us to do. It's kind of prevent, right? You don't want to stress your system every day. Otherwise, it's going to fail sometime. Regular recovery testing, like we should have a recovery testing script. Like what it does is just it's copy that last backup, put into the another system or same system, bring up the database, run couple of testing, and do every day. Why not? Like it's very cheap. You don't have to go buy a new software license. If you are doing for the proprietary databases, you have to get the license for backup testing purposes. So it's very cheap, and it's very easy too. Like it's not that complicated. You can script that, and you can run it in a cron every day, like do this, and if it fails, just email me. So those kind of things can help you to prevent future failures. Like you do vacuums, and sometimes vacuum find out the data corruption or something like that, and you can find out those kind of things without touching the database, without putting more resources to find out what the data corruption is. We use Solaris GFS for backups, like for our internal purpose, like we do hosting too, and we run on OmniOS. That's the operating system runs, it's a fork of Illumos. So we have our own OmniOS, and we use GFS for that, and we take a snapshot every hour. And it's very cheap. It takes like a second to take a snapshot, and you keep it for a week or something, as long as you have a space. Monthly PG dump backups. Yeah. So sometimes it is possible that it's possible for any database system in the world, like there could be corruption caused by the bugs in the software, because there is no software in the world that's bug free. Everything has a bug. So make sure that you take a PG dump every month at least. If it's a small system, you can do weekly, to make sure at least you lose only 1 month of data if there is something catastrophic happens to your software. So I'm not making everybody scared, but it can happen, and it happened for many people with spending millions of dollars too. So it does happen. Okay, so do you have any question about unplanned outages, or do you want me to wait till end of the talk? No question? What? That's the problem. You can't, like, other than like in the past we had a corruption in the index, like unique index. So unless you have some kind of things like you try to insert something, you find the error, right? For the unique key constraint or something. So those kind of things. So it's not possible to find out corruption like for most of the databases I know of. But that doesn't mean that we don't have to try it. We can try our best to find out for prevention. And there are two things you are getting the recovering every day, like you can test your backups, because in the past I had issue like they were taking backups every day, but they never tested it, and it doesn't work when you need it. So why not now? And there are other advantages to do that. Okay, so we are moving towards the next section, planned outages, and for that we are going for the system changes. So major system changes I usually deal with is OS upgrades, and sometimes it's the network outages. That might be you need some kind of changes in network and you need a planned outages. So for that, this is one of the system we came up with, like for one of the customer. So what we have is we have master, we have failover database system. It's SRHS, means streaming replication hot standby, and we have a NAS network system that for copying the WAL files that can be shared with everybody, and we have a read slave one. We have more than one slave, we have a couple of slave, but at least you need at least one extra slave during the failover. So you want to do upgrade, OS upgrade or something that requires to be restart. So what you do is you fail over to the new master, the old slave server that becomes a new master now, and this all three links are broken now. So now the new master is your master database. Your application will try to point to the new master database, and the read slave will connect to the new master, because read slave will always listening to the floating IP. It doesn't. So until Postgres 9.1.90, you have to restart the read slave one to point it to the new master. I think from 9.1, I think it's quit and it's connect to the new master database automatically. So then once the OS is upgraded, new server is in place, old master is now new failover, you put everything back. So this is like, it's not 100% availability, but you get like, you don't have to stretch out for months and months to wait for OS upgrade to get the outage for like half an hour or 1 hour. You can do like with minimal outages, and still you don't dissatisfied your customers, like because your application is still running with short period of outage. So that was a OS upgrade. The next step everybody does is database upgrades. So I just made little chart of it, like if you want to upgrade your database system. I don't know if it is readable by everyone, but yeah. So I assume that everybody is running PG 8.3. Who runs older version than 8.3? Good luck. PG 8.3. Let's assume that everybody has PG 8.3 and above. So if you have lower version, then is outage. There is very limited options you have for upgrade. It's pg dump and restore. You can do that. And I don't know, like from 8.2 to 8.3, you can upgrade using Slowly, but I think you can do that with limited outages. But if you are running older than 8.3, then if you can, if your outage is acceptable, then you still do pg dump restore with the small databases. And if no, then there is a pg upgrade utility we have been using for like year, 2 years. Like on the production, it runs like the simplest thing you can do is pg upgrade check pass. There is a check. There is a command called check in pg upgrade script that you can run to see that your cluster is eligible for upgrade, or it can be upgraded using pg upgrade or not. If yes, that's good, and you can able to use pg upgrade to upgrade your database system from 8.3 to 9.2 now. So if no, because we got that answer no, like we had one of the system had L3 data types and it's not compatible to upgrade using pg upgrade. So what we did, we dropped that incompatible tables during the upgrade. Before the upgrade the system and restore those tables after the upgrade. Still, it required about 30 or 35 minutes of downtime, but not before that. The answer was no, like we cannot upgrade because we cannot take a downtime for maybe a day or so. But now for 1 hour of maybe maximum of 1 hour of downtime, we can upgrade the entire system from 8.3 to 9.1. So there are ways to do that. So I would like to, so this is not the best approach. So you can do different various approaches, but this is the approach we took for upgrading the database system that wasn't compatible through pg upgrade. Data changes. Data changes are not cheap. Like whenever you do some kind of big alter table things, and it might take outage for long period of time to add column with not null or and default. So the good part of is in the Postgres there is a transactional DDL. So you can start begin, make a changes and end it. So it's a transparent, like in Oracle there is no transactional DDL, so it will be, you have to be careful about that. So it's very good feature of Postgres that can you use for the alter schemas. Create or replace views are other things, like you sometimes people hide the details from the table, like they create a view on top of the table and you can add table columns on the tables and then change the view later time, something like that. Then not valid check. So you don't, when you add a new checks or foreign key, it should be validated before. So now in Postgres there is a not valid. So you can add a foreign key, so it will start validating from now, but it will not validate the old records. And we usually add columns without not nullable and no default for the large system, because it has to log the table during the entire time to add a column for that. So that's how Postgres helps you to do the alter changes. And data growth. I think I talked about yesterday about the vacuum is big problem for us right now because of the large systems and the transactions. So Postgres bloat removal, you can do two ways. You can do bloat removal using offline or online. If you run offline, it's a vacuum full or cluster. But if you are running a system higher than 9.0, you should run vacuum full over cluster, because it no longer bloat your indexes. But if you are running Postgres 8.342, then you should always do cluster to remove your bloat. And online, so there is a rebuild index concurrently that can rebuild your index concurrently. So for one of the system, what we had to do is we had to remove the primary key from all the tables, because you cannot rebuild your primary key online. So what we did is we create unique key, not null constraint. So it's about same as a primary key. So then you can do that online concurrently rebuild thing. And we are using PG_reorg for rebuilding the tables online. So what it does, I think I gave a talk a couple of years ago on the entire thing, and you can download from the website. That it does it create a table as, put the indexes on it, and then flip the table and drop the old table. No. Definitely it's gonna take a resource. So her question is what's the performance impact when you do PG_reorg? There is nothing free in the world, right? So when you are running suppose you are doing the bloat removal using PG_reorg for the large table, like let's say we have run it for maybe 70 gig of data, 70 gig of table, 20 gig was bloat. So we removed about 20 gig using that. So for highly, like it's 3000 transactions per second system, we do usually during the off-peak hours. That's time we peak for that. But there was nothing reported from the applications that it was slow. But definitely the system was doing a lot of work. It has half terabyte of RAM. So it was doing a lot of work, but we required to do that PG_reorg because we wanted to get rid of that 20 gig of load from that large table. So there is little bit, and whatever you will run, like to remove that, there will be some kind of resource penalty there, but it's very good tool. Like you don't have to put your application in downtime mode for an hour or 2 hours, and you can rebuild your table. How you work around, if you are running slowly, and if you want to remove the bloat, then you don't need a, why would you do using PG_reorg? Because if you are running slowly, you should have another system. You need to plan that. You cannot do per table. You have to group that in a month or maybe 2 months and fail over your system. Do bloat removal on one system and bloat removal on another system and the next time. So in the Sloney, okay. So don't don't use the failover for Sloney, but use. So always use control switch over called move switch, move set. Okay, I don't work with Sloney, but yeah, but failover is a scary term too. So use that and do whatever you want to do on that system, and do same thing for another system. So I think you are in better shape than me because you are on Sloney. You always run your Postgres system with auto vacuum on. Yes. It depends on the, like, there are some tools. If you go to Omni Labs, there are some tools that PG load report. We cron that every day, and it runs and send out the report, and it will tell you how much is bloat for that table. And from then you take a decision. So keep that decision part to yourself. Don't give it to system. So now we have tools called Postgres 9 now, 9.2 OmniPITR. We do floating IP is very easy to work with. We have OmniTI PG extractor. We have PG_reorg. these all kind of tools we use to reduce mean time to recover. They are all helpful for preventing and all those stuff, but the main goal for me is to recover fast. So now this is the real system we are working with. Like we have application, we have load balancer, floating IP for master, we have failover, we have read slave 1 and 2, we have NAS for storing the vals, for sharing the val files, and we have a backup on the offsite backups in the cloud or maybe on the another data center, and we apply those vals to that running system too. So this is one of the solutions we came up with, but there are different ways to achieve that. But the main thing I would like to point out that if you have a Postgres architecture, and if somebody complains that it cannot achieve the maximum HA, then he or she is wrong. Like you should plan out for that, like, because there is no system in the world that can give you HA solution, maximum HA solution without planning out in advance. Like even though there are some, if you want to do failover, automated failover, you have to introduce third-party tool and use something like, and most of the outage I have seen from those kind of setup is through those third-party tools. Like it, you get outage because of it failed over without any reason. So we usually keep decision part to ourselves, make sure that we need to recover. So for that you need to have backup people who can take a decision. Like you cannot have a single point of failure. So in a team or group of teams, you need to distribute that thing, that if this thing comes up, it page goes directly to this, if doesn't goes this, and this person, and one of those group can take a decision to do failover. I think it might be much better than taking decision from the system. So these are a couple of references I used for giving this talk, and you can download some tools from labs.omniti.com, like the PG extractor, then bloat report. PG reorg is under PG Foundry, so you can download from PG Foundry, and the Postgres docs is the best docs in the world. And thanks for PG Open Conference Committee for giving me opportunity to talk here, and OmniTI who sponsored me to come here. And of course, the talk cannot be complete without you guys. And today I'm taking questions, so you can ask me question today. Okay, his question is, do we really need that failover system and this read slave? So the reason behind that is that failover system is same capacity as master, but I can have a lower capacity system here. There are more than two. Yeah, you can do that. But failover, like there is nothing to do for failover system, like it's not reading anything. So I don't want to put any extra load on this read slave. Just do his job. That system's job is to do, whenever there is something wrong with the master, it failover and take backups. At least it has to do something, right? What he is going to do sitting there. Sorry? SRHS, streaming replication, and it's hard standby, so it's doing streaming replication and wall shipping too. So yeah, we always go with the we call it hybrid streaming plus wall shipping. I think I completed before time. Mhm. It changes the catalog. Yes. Maybe it's less complicated than Sloanie, but okay, not anymore. Okay, that's good. No. So thank you very much.